Hello, welcome back. Today we're going to be talking about solving equations with more than one variable. The objective is that by the end of this video, you should be able to solve an equation with more than one variable. We have a couple terms to discuss, some of which are familiar. The first one is like terms. Like terms mean that you have the same variable with the same exponent. In other words, it's the same letter and they have to have the same exponent. Also, constants are considered like terms. Literal equations. Equations that contain only variables. An example would be y equals mx plus b. Notice there are no constants anywhere inside of that equation, and the coefficient of x is also a variable. Our goal is we're going to try to get only one variable with the coefficient of 1 on one side of the equation, and every other variable and or constant on the other side of the equation. So we're going to be solving. Remember, that's our goal for solving. To review how to solve, you must simplify both sides of the equal sign first, including combining like terms, and then you must do opposite operations in SADMAP order. Now, I've changed the way this was written from the previous video. First thing we're going to do is if the variable you are solving for is on more than one side, remove the variable from one of the sides first. Notice there's nothing on there about checking your answers, because when you have a literal equation, it makes it a little bit more difficult to check your answers, so we're going to skip that step for this unit. So now I'm going to solve some literal equations for the variable a. It is a good idea when you're solving these equations to box the variable you are trying to solve for. This is a visual way to keep track of what letter you're trying to get by itself. Now I'm going to split the equation into two pieces, the left side and the right side, and I've got to get a by itself. So you need to ask yourself the question, what is with the a on the same side as the a? The answer would be the plus b. Well, solving in SADMAP order, how would you undo the plus b in order to get rid of it? The answer is you would do a minus b, because they're opposite operations. So we subtract b from the left side, means we need to subtract b from the right side. This looks a little different, but it's not a big deal. We bring down the a, because we didn't do anything to the a, and a positive b, take away a b, is no b at all. You don't have to write it. Then we're left with a c and a minus b. Now, I cannot combine the c and the negative b because they are not like terms. They're not the same letter. So the only thing I can do is rewrite it as c minus b. So it's c, take away b. Let's take a look at the next example. A, b, c is equal to d. This means a times b times c is equal to d. So again, I'm going to box the a to let myself know that's the variable I'm trying to get by itself. And it's attached to the bc through multiplication. The reason I know this is because the a is next to the bc, meaning it's being multiplied by the bc. So to undo the multiplication, we'll divide both sides by BC. The BCs are going to divide out to give me 1, leaving me with just A is equal to D over BC. Let's take a look at our third example. Again, we're trying to get A by itself. And this one's a little bit more complicated because we have several things on the same side as the A. Let's go ahead and split our equation into two pieces. We have the b, we have a negative symbol, and we have a c. We're going to solve in SADMAP order. So we're going to undo subtraction or addition first. Notice it is a positive b minus the ac. So I'm going to get rid of the plus b by subtracting b from both sides. This is going to leave me with a negative. Notice the negative stays with AC. Negative AC equal to, I can't combine the d and the negative b, so I just have to go d minus b. Now, I still have a negative and a c left with the a. It's a little bit tricky, but I can get rid of the negative and the c at the same time by dividing by a negative c. So I divide the left side by negative c, I can divide the right side by negative c. The reason this works is because a negative over a negative is a positive, so I got rid of the negative sign, and c over c is 1, Altogether, this leaves me with just a. A is equal to d minus b over negative c. If you're feeling fairly confident that you can solve these equations on your own, please go ahead and work each of these out and press play when you're ready to see the answer. If not, then I ask that you try to anticipate each step as I'm working it out. It'd also be a good idea that if you got it wrong, to replay the video and rework the problems. For the first equation, we need to get r by itself. So we look in the left-hand side, we notice there's a 2 and a negative c along with the r on the right-hand side, and the 2 and the minus c is on top of the r. So r is trapped in the denominator. We're going to do something a little bit weird. We're going to multiply both sides by r. And watch what happens. R times 2 minus c over r, the r's will cancel, leaving us with just 2 minus c equals to k times r, or kr. Again, what that allowed us to do is to get the r out of the denominator. Now r is on the right-hand side with the k. The k is being multiplied by the r, so we can undo that multiplication by dividing both sides by k. And we're left with our final answer as r equals 2 minus c over k. Solving our next equation, for b, again we box the b. Hopefully you subtracted a from both sides, giving you p minus a equal to, still left with a positive b minus c. And hopefully you added c to both sides. C is not a like term with the p, the minus a, or the c, so you can't combine them. So we're just going to write it as p minus a plus c equal to, this negative c and c canceled, so it equals to just b. We have b by itself on one side of the equation, so we've solved the equation for b. On to our last example for solving literal equations. In this one we were supposed to get t by itself. Notice there's a v with a 0 on the bottom. That means v naught or v0. That's a variable all by itself. To get rid of the v0, again we're going in sad enough order, so we're going to undo the subtraction or addition first. Since it's v0 plus gt, we're going to undo that plus, since it's a positive v0, by subtracting v0 from both sides. V minus v0, they're two different variables because of that subscript. We just write it as v minus v0 equal to, so these v0's cancel. We're just left with a gt. We still need to get the t by itself. Sorry, I forgot to box the t. And we notice there's a g left with the t next to the t. So we undo that multiplication by dividing both sides by g, leaving us with our final answer, v minus v naught over g is equal to t. Since t is by itself, we've solved the equation for t. We have a little bit more terminology to finish out the video, which is to write an equation so that y is a function of x. This means that you're going to solve for y, or get y by itself on one side of the equal sign, and every constant or variable on the other side of the equal sign. Let's take a look. 5x plus 2y equals 7. We're going to rewrite the equation so that y is a function of x. To do this, again, we've got to get the y by itself. So, split our equation into two. I'm boxing the y to let myself know I need to get the y by itself. And we're going to go in the reverse order of operations. So we have a 5x plus a 2y. To get rid of that 5x, we can actually take away all 5x's at the same time by subtracting 5x from both sides. 5x minus 5x cancels out, leaving us with just a 2y. Then we have 7 minus 5x. We now have a 2 times the y. To undo the 2 times of y, we're going to divide both sides by 2. This leaves us with y is equal to 7 minus 5x over 2. This is mostly the end answer. However, when solving equations, we can simplify this a little bit more by dividing both terms by the 2. Both terms means dividing the 7 and the negative 5x by 2. So we get 7 over 2 minus 5x over 2. And there we have solved our equation for y, or we've rewritten the equation so that y is a function of x. I have 3 equations for you to rewrite so that y is a function of x. Please try all 3 of these on your own, pressing pause, and when you're ready to see the answer, please press play. Alright, for the first equation, needed to get y by itself, so I subtracted 6x from both sides. Remember, we're going in reverse order of operations, leaving us with a 2y is equal to 8 minus 6x. In the future, we're going to go ahead and rewrite that as negative 6x, and that's a positive 8, so we're going to write plus 8. It's just a common occurrence in math that we always write our variable first and our constant second. So, to get y by itself now, we divide every single term by 2. Terms mean that you have 2 items separated by a plus or minus sign. The negative 6x and then the 8 are separated by a plus. So we divide both the negative 6x and the 8 by the 2, leaving us with y is equal to negative 6 over 2 is negative 3x plus 8 over 2 is 4. Taking a look at our second example, we're going to go ahead and subtract 3x from both sides. Leaving us with negative y equals to negative 3x plus 12. Then we have a negative with the y. You have 2 choices. You can either divide everything by a negative 1 or just change the signs of every term. I'm going to choose to divide everything by negative 1. This leaves me with positive y, because a negative over negative is a positive, equals to negative 3 over negative 1 is a positive 3x. Positive 12 over negative 1 is a minus 12. And we've rewritten y as a function of x. For our last example, which is a little bit different from the previous 2, we still split our equation into 2 pieces, and we're going to try to get y by itself now on the right-hand side. To get rid of the positive 9, we subtract 9 from both sides. In this example, we can actually combine the negative 5 and the negative 9 to give us negative 14. And we bring down our 2x. Equals to, the 9 minus 9 is 0, so we don't have to write it. And we bring down our minus 4y. We still have a negative 4 times the y, or next to the y, so to undo that multiplication, we're going to divide everything by negative 4. This leaves us with y is equal to negative 4 over negative 4, remember, is a positive 1y. 2 over negative 4 reduces to a negative 1 half x. Negative 14 over negative 4 reduces to a positive 7 over 2. So there you go, there's your final answer for your final example.